You can do varieties of things while working with MATLAB. For example, the more humans we have on the earth, the more babies we can have. Then those babies will grow up and that produces even more babies. The population will grow faster and faster. The world's current population is around 8 billion, and when you finish watching this video, till that time around 2000 babies would have been born. But the question is, why I'm telling this to you in MATLAB tutorial video lecture series? Now that's the point. If you want to do research or study like how much population changes by time, or you are dealing with control system when your input changes in step and you need to make some changes in output in accordance with your input, then you need to use differential equation. And in this video I am going to tell you how to solve differential equation in MATLAB. So without wasting time, let's get started. Now for example, we have an equation 2 minus x squared and we want to differentiate it with respect to time. So let's write a script for that. So let's say our output has two variables. One is t, time, and the another one is x. And now we want the differentiation. So we will go for command ODE. ODE represents ordinary differential equation. And there are varieties of methods through which we can solve ordinary differential equation. Here we are using ODE 23. Now into bracket, first we need to define ODE function. Here you can see, first we need to define ODE function. Let's say suppose our function is f. Then you need to define t span. T span means your time span for what amount of time you need to differentiate this equation. So let's say our time span is t, and then the initial condition. What would be the initial condition of x? So let's say our initial condition is 1. So this is the equation, but here we have not defined the time span and function. So what we'll do, before this equation we'll define time span and equation. So let's say this is our time span, and now I'm going to define the equation. There are various methods to define equation. One of the simplest method is inline equation, defining equation in line. So for that we'll write, what is our equation? Our equation is f. So we'll write f is equal to, we have variable t and x. So f is equal to @ tx, and now into this bracket we'll write our equation, and the equation is 2 minus x squared. So there we go, and now we'll save it and run it. And these are the different results of differentiation. Now let's plot these results into the graph. If you want to have smooth curve instead of these slanted lines, then here you increase number of points and then you can have a smooth line. So this is one of the way of solving ordinary differential equation. Now I'll show you some another method. Now for example, our equation is minus y plus ku by x. This one. And we'll solve it a little bit differently. So we'll write ODE equation for this. Now instead of ODE 23, we'll go for ODE 45. Now first we need to define ODE function. Let's say our function is f. Now we'll define time span. Now here we'll define it a little bit differently. We'll say 0 to 1, comma, and now we need to define initial value y0. I can directly put the y0's value, or I can take this as a variable and then define it in the same script above. So here first we need to define x. So I have just randomly defined x is 4, k is 2, u is 1 and y is 0.5. Now we'll plot this t and y. And this is the result. See, this one is the simple function. But what if your function is more complex? In that case, you can create a separate user-defined function for your specific function, and then you can directly call that user-defined function here with this OD function to get the differentiation of that equation or your function.